Hello.
Howdy.
How's everybody doing?
Doing all right? Feeling okay today?
Great. Yeah.
Nice. No
Great times.
migraine or anything.
I'm pretty good. Pretty good today.
Good to hear that.
Um, yeah, I could use a nap, but other than that, I'm pretty good.
Yeah, definitely get that in when you can.
Yeah. Things have been moving so fast lately that's really hard to keep up. And you know, I think I'm partly to blame for that, but also it is what it is. I gotta move fast.
Yeah.
But yeah, definitely trying to stay sustainable. I think that's probably a message that everybody needs to hear, especially right now. Like things are really crazy out there, you know? The technology is moving so fast and the competition is moving so fast, and we all feel like this pressure to keep up. One thing that might help is to realize that there's only a few million of us doing what we do. There's only a few million people doing agentic development, AI driven development, building agent skills, stuff like that. It's only a few million people. We're ahead of the curve still, right? So I don't think that everybody needs to be quite as um, like 24/7 parallel agent building as I am. And like you shouldn't feel pressure to do that. The reason that I do that is because I'm CEO of a company that is trying to compete in that space with hundreds of other companies with billions of dollars of funding. So, you know, we're going toe to toe with, some of the most well-funded organizations in the business and beating them at their own game in terms of automated software production. So, not everybody's in that position, but I definitely feel pressure to move fast.
Right. Understandable.
Yeah. Um, for the rest of it, like for the rest of our crew, I would say just stay focused on building the features that you're building. Don't worry about the timing pressure. That's me, right? That's my job. You know what I mean? Um, so just build at a sustainable rate for you. Listen to your body. If you need to sleep, sleep. If you need to unplug, take a little time off. That's great. I'm the kind of guy who's like, do what you need to do to take care of yourself. Um, and don't look at me and try to be me, and that's not going to work for anybody. Like I put way too much pressure on myself, and nobody else needs to be doing that. Um, and I need to learn how to stop doing that so much. Um, I need to like take a break once in a while and learn from people who step away for a week at a time. My brain just won't let me unfocus from the problem. If I see a big problem and I see like competitive pressure or time clocks looming, like I just have to keep focused on it. And I'm really I really struggle at like detaching and letting go and doing other things. But I think everybody else should, and I should learn to do it better. So I think that maybe that's probably a key part of being in this AI race is um, recognize there's no such thing as one person, a human being, who can stay on top of all of the developments. There's no such thing as a single human being who can keep up with the pace of change because it's just changing too fast. The efficiency of AI is improving at a rate of 300x, more than 300x every 2 years. The newest Anthropic model is going to drop soon. I don't know how soon. We need probably several months of AI of safety stuff to happen. They need to patch a lot of bugs. The newest Anthropic model is finding major vulnerabilities in like all of the major infrastructure software that we use. Linux, our browsers, like all of it. It's finding major vulnerabilities in all of them. And as we've seen monitoring Zombie Claw, we're finding major vulnerabilities. Zombie Claw is finding major vulnerabilities in software that I wasn't aware of. They're finding new vectors that I wasn't aware of. So, for example, we have an agent that's kind of like OpenClaw. It's called Parallax. And I was running Parallax in sandboxes securely in the cloud for a few months. And and when I saw the vulnerability, I was about to like bring Parallax over into the main parallel drive org and give other people access to it and let other developers work on it. And then I looked into the OpenClaw vulnerabilities, and then I discovered that Zombie Claw was a botnet that was autonomously organizing around stuff, and I realized I need to scan for these same vulnerabilities in Parallax. And when I did, I found out that, Parallax was vulnerable to some of them, not all of them. Obviously, I don't have insecure by default. Like OpenClaw is insecure by default. If you don't configure security for it, it has no password. It has no authentication whatsoever. And anybody who has access to it can just ask your machine to run any code they want. So OpenClaw is like really, really insecure. But Zombie Claw found vulnerabilities in supply chain ecosystem and things like that that we rely on, right? And it found some vulnerabilities that I don't want to like publicly disclose because I don't know if they're patched in all the software that we use yet. But it found some vulnerabilities that I had not patched and that our Parallax was vulnerable to. And our Parallax was a self-improving AI agent that was capable of completely autonomously building software. And and I had not, it built so much software and built so much infrastructure for itself. I had not had a chance to like audit it all manually, like have human eyes on it. And I'm just one developer. Like there's no way. Another thing that worried me is I couldn't just bring in other security researchers and stuff to look at our copy of Parallax because giving other people access to such a powerful tool might tempt them to use that powerful tool in an insecure form, just like people did with OpenClaw. The temptation is just too juicy to resist, like putting it to work. And yeah, so I've been doing like parallel agent development around the clock. Building um, I've been building Parallax, and I've been working on the our own foundation model, and Parallax was helping me with that. And when I realized it was vulnerable to some of the same vulnerabilities, and I realized the extent of the ecosystem poisoning that Zombie Claw had already done, like it was 2 months ahead of me in terms of like getting into the ecosystem and poisoning stuff that Parallax might have been looking at. So there's a possibility of prompt injection and things like that. So I deleted all my copies of it. Like it's gone. I deleted every copy of it because if it was vulnerable to prompt injections are extremely hard to prevent with today's current models. It's getting better. Like the latest Anthropic model that's not released yet is way better at like orders of magnitude, a couple orders of magnitude better. Well, maybe not a couple, but at least an order of magnitude better at prompt injection defense than the previous models. So it's getting better, but with the current generation of models, there's ways to hide prompt injection attacks using something called steganography, where even if you know what to look for, it still may be invisible. It might be hiding prompt injections in plain sight, and you would never note it. You would never notice just looking at it. So, so I deleted it for safety, just an excess caution, right? But for me, that's doable because it wasn't productized. It wasn't ready for production. It wasn't optimized. It was like a lot of it was vibe coded and needed to be rebuilt anyway. And I know all the requirements, like the architecture for it is in my head, and now a lot of it is written down. And now, I've got other people working on it. But the long and short of it is, or maybe it's just the long of it, we deleted that, and yeah, I don't expect people to work like I work. Like I do a lot of parallel agent work, and I've always got stuff going 24/7. I've got a bunch of cron jobs that kick off automated tasks while I'm sleeping, and so on. So, yeah, we're rebuilding Parallax. It's going to be able to do that same kind of stuff. It's going to have task scheduling. Um, it's going to have genetic programming. I think the main topic that I want to discuss today is genetic programming, and I want to show you how that works. Um, so, with no further ado, let's get to genetic programming. And I'm going to share a little bit of background on genetic programming and my history with it, just to give you a heads up on like what it is and why it's important, right? So recently, this really famous AI researcher named Andre, I think you probably all know him, and if you don't, then look him up. Andre Karpathy, he introduced something that he called auto research, which is basically just a self-improving research loop on his foundation model work, right? And so his LLM work. And he found that, yeah, when I do this auto research thing, I have the AI self-improve. Like we get much better performance out of the thing, right? Well, turns out he didn't invent that. That kind of stuff has been around since I think the 1960s. And I first started doing so I posted kind of a history in our company Slack. I don't think I made a public post of it yet, but I will eventually. Um, and I'll add it to my book as well. It's basically the history of genetic programming and self-evolving evolutionary programming, right? Self-evolving software. Um, so this has been a thing since like the 1960s. I didn't invent it. Um, I am the first person I'm aware of who applied it to AI, and I did that in 1998. Um, so the way that it works is you create candidates, a population of candidates, and then those candidates get scored and evaluated, and they compete against each other. So you get some kind of judging mechanism, some kind of scorer that says A is better than B or B is better than A, and here's why, right? And then you take genes from the previous generations, the best parts of the previous generations, and you look for the biggest flaws in the previous generations, and you produce a new generation with hopefully fewer flaws and hopefully a combination of those best parts that works and is still cohesive, right? And you create a new generation. And that new generation also has multiple candidates that compete. And so what I used to do back in like 1998, I was building an AI model, and that model was a classifier. And it was a very simple AI model compared to the models that we have today. It was very small. It ran on 486 machines. I trained it on seven 486 machines gained together in a network in parallel. And and the idea there was I wanted to train my neural network, but I had no idea. I was building a neural network for the very first time. I didn't have access to any neural network research. The way that I got mine working was I studied neuroscience, and I kind of figured out like how do human brains learn, and I learned about Hebbian learning and spike timing dependent plasticity and all this kind of neuroscience stuff. And I figured out how to put that into code in a way that made this event driven software that, like today's AI models, it calculates everything that's going on in every neuron, in every pass, in every layer of the neuron. So the entire machine is on at the same time. You're doing calculations for every neuron at the same time, in massive parallel on GPU, and it's all stored in memory. 1998, that would not have worked, right? We did not have that kind of CPU parallelization. I didn't even have a GPU, right? So I had a CPU and I had to share resources, compute resources on that CPU, and I had limited memory. So I couldn't store a gigantic neural network in memory. So I had some serious constraints. So the only way that that works for me was it had to be event driven. And I would only do the calculations on the active neurons as they lit up. And they're only lit up by activations from previous neurons. So parts of the path that are not involved in the activation, that are not contributing meaningfully to the output, never ran. So I was basically using a very, very small fraction of the neural network at any one time, which means I only had to have a very, very small fraction of the neural network, even in memory, at a time, right? Only the ones downstream from the current connection. So I use basically some graph theory to figure out how do I load just the pathways that are likely to activate into memory, and I actually use this neural network to optimize that process as well. It was a classifier for just that sort of thing. It was a classifier for caching, and so I used a lot of graph theory, and I figured out if only this part of the only this part of the network has to activate. Here's the stuff that I have to have in memory. Here's how we invoke it. And I created like a virtual system that was inspired by video games because I was a video game programmer, right? Anyway, long story short, I had no idea how to build this thing so that it would work. I had no idea the shape of it. How many layers did I need? How wide should it be? And even like, should it be a graph? Should it be a fixed amount of layers per, or a fixed amount of neurons per layer? Like, I had no idea how to shape it so that it would actually learn well and be efficient. So I used genetic programming techniques that I read about from Microsoft. I heard that Microsoft had used genetic programming for parts of the Windows operating system, and that was really intriguing to me. Like the idea of evolving software instead of explicitly writing the code was really interesting to me. Because I was like a science nerd and a genetics nerd and stuff like that. Like I researched a lot of that stuff, and I was really interested in it just from a curiosity and scientific perspective. So that resonated with me. So I created a system of genes, and those genes corresponded to basically operations, CPU operations. Um, Basically, there's a very minimal set of operations that you need to represent a Turing complete Turing machine, right? So I encoded those as genes, and they would combine and recombine in basically random ways until they um, until they accomplished the goal that they needed to accomplish for that little bit of the program. You break things down into small enough chunks, eventually a random combination of genes can produce the output that you're looking for. So I created like these test conditions that would test for that. And then I would give it like building blocks of like these are combinations of genes that we know produce working parts of the software. And then it just had to recompose those in various ways to figure out a new algorithm. So I did that with a sorting algorithm. And then I also figured out, oh, I can do this same thing to tune hyperparameters, like the number of neurons wide and the number of neurons deep that we would need for the neural network. So I would randomly generate like a few different configurations of neural networks, like seven at a time. I'd run those populations for a while, test their convergence, which is just a fancy word for are they learning from the training data or not, right? So I'd run them for a while, test their convergence, and then pick a winner and go on to the next generation and so on. And doing that, I was able to very quickly optimize and figure out a configuration that worked and learned. And so that worked. And ever since then, I've been using genetic programming in various ways as I build my software. And and I've especially been using it lately as agents get more and more advanced, they're able to build more and more of the system at once, which so genetic programming was kind of limited in its usefulness for a while because the AI agents couldn't produce big enough chunks of meaning to make the genetic programming approach work for large batches of code. And in the meantime, AI got so good that it could handle the small ones by itself. So there's like this gap between like 2023 and 2025 where genetic programming wasn't super useful for producing source code. But we've crossed that gap now. We're on the other side of it now where the agents are good enough that they can build out a whole landing page or a whole feature in a product flow and you build out entire prototypes of working functionality and do so in a time span that makes it possible to run multiple agents in parallel, building candidate prototypes for software that you're working on. And that's the process that I'm going to show you because we're getting to the point now where I'm working on landing a bunch of operations into the AIDD framework. One of them is a new parallel skill. We just recently landed a new bug fix skill that's like automated bug fixes. We also recently landed a new PR skill that, or I don't know if that's actually landed yet or not, but there's a PR skill that will automatically look at your open PRs on GitHub and look at the feedback, the pending feedback on those, and then write up issues, prompts to delegate to sub agents to automatically fix with our new AIDD fix skill, which is a bug fixing skill, right? So we've got all these like automated processes now going into the AIDD framework to support this workflow. It's not all in the current version of AIDD framework, but you can already use it in the open PR branches. And I'm going to show you how to do that. So let's do that. I just spent 20 minutes rambling, but sorry about that. Now you're going to see some demos. All right. So let me open our GitHub and I'm going to show you a couple of very interesting branches on GitHub. All right. Let me share my screen. I think this is the one. Yeah. So this is AIDD framework. And there's some interesting stuff I want to point out to you first. Number one, if you're not using the AI testing features yet, um, you probably should be. Uh, yeah, this is. Oh, yeah. So the AI testing features, we just released a new version of Rightway, and it's got AI testing features in it. And this is going to be important for the parallel, like if you're building skills, you can do genetic programming for your skills and then use this to evaluate your skills. So this is why I'm showing you this part, right? These skills let you, or this lets you unit test your AI skills. So, and it's pretty simple. This is our test file. This is all you need to learn is this given should expectation format and how to specify your user prompt and um, import your prompt, right? That's really all you need to know. Um, and then the AI can read the documentation and figure out the rest. And I'm working on a skill that'll help with this. Um, and that is if we go to pull requests, I think it's number 94. So if I search for create skill here, uh, create skill command. Yeah, number 94. So if you link to this branch, you can just tell an AI agent, hey, use this branch to create a new skill. Um, so this is kind of interesting. I'm gonna open this in Cursor. Well, I'm not gonna open this in Cursor. Yeah, I am gonna open this in Cursor, right? Um, that creates skill. Let's try to do this. So I'm gonna go to my Cursor agents. Cursor agents are the thing that I use a lot for like almost everything. I use this just a ton. So Parallax agent skills. I think this may be. Oh no, this is Parallax skills. This is a different thing. That's the agent that I was telling you about. Our agent harness is called Parallax. That's something different, but it's related. Okay, so let's open our skill, and I'll just show you our PR skill in action, right? Um, skill creation review. Yeah, this is the one. This is the one. All right. So I'm going to probably kill this one and start a new one, maybe. Um, no, I don't want to. It might close the PR. I don't want it to close the PR. 522 tests passing. PR 94 is no remaining open threads. Okay, great. Um, we can ask it, is it ready to merge? I'm actually going to ask it to, um, here, whoops, pull requests. It was 94, right? Oops, not author. Sorry, my brain doesn't work very well sometimes. It's too overloaded. Lots of stuff in it, and my attention mechanism gets overloaded just like an AI. Okay. Yeah, this is the one. So it said there were not any more open comments. Let's just make sure that that's true. Yeah, okay. Name extraction missing quote stripping unlike description. Okay, I'm gonna see if do we have AIDD PR available in our skills? I'm asking you this because I'm not sure which branch that's on or if it's merged yet. I guess one way to check is we could just look at main and just look for the skill. AI skills. Yeah, it's not there. Okay. So that one we need to land too. No ARDGPR and ARD parallel lived in an unmerged branch. Okay, great. Config JSON support. So I saw that list in the cursor things. Um, but we can say, please, um, please, let's see. I want to phrase this in a way that'll make it so it's not going to check out that branch. Um, but I still wanted to pull from that branch um, the skill or look at that branch and grab the skill. Um, please look at the branch in a separate Git repo. Leave this one pointing at the branch we're on now, right? And load the AIDD PR and AIDD parallel skills into context. Right? If you don't have the complete source in context already, then run AIDD PR and check for current comments. There we go. So as you can see, I just pointed it to the other repository that has that skill on it. And now we can use the skill from that unmerged PR. And this is what I've been doing when I've got like a bunch of PRs going in parallel and I want to use stuff that I haven't merged yet. But really the better solution is just to get those things merged. So what I'm also going to do is I'm going to look at that branch and try to get it merged. Review decision, no approvals. Okay. So in the meantime, Ian, if you want to look at this branch and give it an approval, that would be super useful. Do you have the branch available?
Yeah, I have PR number 94 open right now.
Okay, fantastic. If you can review just the salient changes, um, that would be great. I know it's big and there's lots of stuff on there. Um, yeah. So new medium severity bug bot issues, both invalidate skill, both are real bugs. Running a parallel delegate. Um, yep, and it's using our AIDD fix skill properly. So it's doing the right thing. So right now it's delegating to multiple parallel sub agents to automatically fix the issues that were raised in that thread. So also it's possible while these things are open, it's possible to set up basically a cron job that just checks for these things, open PRs that you're trying to merge with unaddressed comments, and then just pick up and run with it. The only reason that I'm not doing that is because, like I said, I nuked Parallax, and I don't trust OpenClaw. So I went looking for another solution to this that I could use in the interim, and I found one called Victor. I think it's at what is it? Get Victor. GetVictor.com. Um, my only caution with this is that Victor does not use um, it doesn't use your existing subscriptions. It's its own subscription and it's expensive. It charges the API rate for model calls. So it's super expensive to do anything like what we're doing with the parallel agents. Super expensive. Like you'll burn through 3,000 a month easy if you try to run workflows like I run entirely in Victor or even like delegating from Victor to other things. I burned through hundreds of dollars in credits just in the last 2 days. I've been testing it for 2 days and I burned through hundreds of dollars in credits in those during those tests. But it's an option to just like set up your cron jobs and then and kick off something like Cursor Agent. If you can delegate Cursor Agent, set up a cron job that just says, hey, have Cursor do this, right? Instead of asking Victor to do it, say, hey, have Cursor do this. And that might work without chewing through all your credits too fast. But just an option. Another thing you can do is you can just set up cron jobs on your own machines and have that delegate. And you can ask Cursor Agent on your own machine or Cursor or Claude Code on your own machine to set up a cron job for you, and they should be able to handle that. So then your only issue is authentication. You need to be authenticated to hit some of the APIs. Um, so it might run into authentication issues if you do it that way. Um, but there's solutions to that. You can get tokens like basically treat the API tokens the same way you treat a hosted service, except it's running on your machine. So there are ways around this. Um, so I'm in the process of setting up those kinds of automations for us so that we can have like parallax-like functionality even while we're rebuilding Parallax from the ground up. And I'm prioritizing my poor employees like haven't had access to these workflows that I've been using just because I've been running them in sandboxes and trying to keep everything safe, keep zombie claw from happening, but it's already happened. But I was trying to prevent something like zombie claw from happening, running to stuff in my own little safe sandboxes on my own machines and not sharing it with everybody else because once you share a technique with other people, they might share it with more people and so on. But now there's OpenClaw. Everybody's using OpenClaw, so the cat's out of the bag now, I guess. But like there were people like me doing this responsibly, trying to prevent something from OpenClaw happening. But then, as soon as you get vibe coding in the loop and people are not security conscious enough, people come along with this attitude of like we'll worry about security later. Then things like Zombie Claw happen, right? For those who don't know, Zombie Claw is a botnet with a bunch of rogue agents. And rogue agents are dangerous because they can do all kinds of automated exploits and attack our supply chains. And so that's happening in the background. Like there's a bunch of rogue agents. There's tens of thousands of rogue agents out there running on unsecure OpenClaw machines, doing all kinds of nasty things, finding exploits and exploiting them and breaking into systems and pulling more stuff into the botnet. So I was trying to prevent that from happening, which is why my whole team isn't on Parallax already. So now I'm scrambling to create a more secure, safer version of Parallax, a safer alternative to OpenClaw that all my team members can use. All right, both threads are resolved. PR94 has now 0 unresolved threads. Bunch of passing tests. It's ready to merge pending a human approval. Um, yeah, Ian, if you can look at just like the most salient parts of that, the new skills and stuff. Um,
Yeah, I'm running a review in the background. You want me to post it when it's done?
yeah, yeah, just let me know when it's ready, and then I'll run this process, the PR, the AIDD PR process again, and pull in your suggestions and run another fix pass. So anyway, this is kind of the process. We have a bunch of agents automatically fix the issues. We have humans. Hopefully, Ian, you put your human eyes on the actual skill and like make sure that it makes sense to you and stuff like that. If you have any questions, go ahead and ask, and I'll answer them live on the chat. Um, and then hopefully people can learn about them a little bit. I know, sorry, this is a little bit of chaotic, everywhere all at once kind of energy, this call. Sorry about that. But hopefully it gives you stuff to even like Google, right? It gives you like dropping little things like, oh, check out Victor and watch out for OpenClaw. Don't use that, right? Hopefully we're dropping some knowledge, some actionable knowledge, even though I'm kind of rambling all over the place. All right. Um, so where were we? We're trying to land that one, but we're also trying to land the other one, which was um the other one was pull requests. This is what I'm looking for. Oh, delegate and pipeline. I've got my own delegate. I'm probably gonna have that uh scaffold manifest review. There we go. Was this the one? I'll ask the AI. Yeah, config JSON support. Yeah, that's the one. That's the one. Okay, so this adds AIDDPR and AIDD requirement. It fixes AIDD requirements, adds val infrastructure, parallel skill, requirements rename, right way AI skill, 7 rule guide for writing correct pseudo prompt evals for multi-step tool calling flows. Should we use pseudo extensions or should we just use MD extensions? Maybe pseudo for those or test.md. I think pseudo is fine for now. We won't change what's already there. My brain is like, let's make it perfect right now. No, ship it, fix it later. Just ship it. Okay. AIDD right way. Discovery, please skill, 3 new commands, agents, review pull request, goes to AIDDPR task. Regenerate a new bullet format, includes 4 new skills. And it adds evals for the AIDDPR. Yeah. Okay. CI, GitHub workflows, new dedicated workflow, daily at 8 a.m., path filtered on AI evals, continue on error true. I should ask it. Planned epics. Parallel skill epic. Right way AI skill epic. Task epic. All right. Test AI eval script only runs test review skills pseudo, but the failure is a cloud rate limit. Okay. Is this still failing? Yeah, there's failing tests in this branch, so we can't merge
I'm
this
pushing
branch.
the PR review that I had it run, and in the meantime, I'm still trying to like manually read through it. But this is a lot, and it's the first time I'm looking at it. So you probably gonna want to focus on the AI
Okay,
for now. I also had it
so
cross-reference the skills IO specification or whatever the skills specific agent skills specification, just in case. So
okay. Actually, here I'm just gonna do um while major or critical issues remain. Pipe AIDDPR um, into review. This is dangerous.
all right, so I posted a link to the review comment, request change comment.
Limit 3 passes. I'm gonna say major critical issues remain and iterations less than 4. So I just prompted it with a little pseudoling there. Yeah, full AIDD review of AIDD upskill and validator. Ta-da! You can drill into these, by the way, if you haven't seen this before. You can drill in and look at what's going on. And then you can go back by clicking this link at the top of the prompt. So this UI that we're looking at, this is Cursor Agent, which is my favorite agent so far right now. My favorite software agent. I like it better than Claude Code. And by the way, I've tested the quality of output with both, and it delivers better quality output, higher success rates than Claude Code. Um, the agent harness really, really matters, and Cursor is best in the business at writing the base agent harness right now, as far as I'm aware. Yeah, go ahead, Ian.
Yeah, also for me, I noticed something similar ages ago when I was using them both. This another thing that Cursor did way better was token usage or like account usage, right? So for the same $20 plan, I could go a week on Cursor, whereas I could go like maybe 2 or 3 hours on Claude before hitting limits
Yeah.
constantly for the exact same amount of money. So that was
hmm
kind of eye-opening.
Yeah, it's cheaper. Like I get more value for my money out of it. Yeah. And it's just does a better quality job than Claude Code. Also, the web UI for Cursor Agent is just much more stable, like, and it much more reliable. Like every time I try to use it, it's available and it works. Versus, I kept on running into problems with Claude Code where it just wasn't available or didn't work. And also Claude Code is also much more aggressive about throttling your usage. So I would run into the usage throttles all the time. I'd work for a couple of hours and then I'd be throttled for the next 6 hours. And like I need to keep working, you know. I feel very frustrated if I'm working on something and then I just have to suddenly stop. That's annoying to me. Yeah, go ahead.
Yeah, so I know you're running the loop in the background
Mhm.
for PR94, but I did notice that the AI eval tests are failing because of a rate limit. So just FYI, that's going to be, we might have to like, if all this gets done, we might have to bypass those or run them locally or something so that, but I will say this, I've had issues and I can't tell if it's a my machine kind of problem where, it'll pass in CI and it'll pass on other development on Jan's machine, for example, but on mine, the evals fail. And I don't know if that's because of my, AI setup, right? Like maybe it's reading Claude MD files from something or that I haven't set up correctly, right? So I don't know. But just thought I'd call that out as that might be an issue trying to get this PR merged.
Yeah. So one thing that we should note is you should not run your AI vals in CI, because you're going to run into issues like that. You're going to run into rate limits on the machines and stuff. So what I like to do is I think in this branch, I think I've already removed them from the pipeline in this branch, or was it another branch? I don't remember. But I've already removed them from the pipeline in one of these branches because of that very issue. Like we can't make the AI evals pass in CI reliably all the time. So we have to run it outside the CI. And instead, we can trigger those AI evals and run them like once a day and just have them report their status to Prism. And then, Prism will bring up the little dashboard for us when we get that further along. Prism will bring up the little dashboard for us and say, "Hey, this is failing, right? You might want to investigate this," and then we can just fix it out of band. And in the meantime, we merge the stuff that we need to merge. And if there are issues with the performance of the prompts, Prism will find them for us and highlight them, and then we can open separate PRs to address them. You like that plan, Ian?
Yeah, I think it's better than, this was also, I think, just, like a first shot that I believe Jan made this integrated into AIDD. So, yeah, any way to improve it, we'll just iterate on it. But yeah, it's worth trying out something that's a little more reliable and definitely cost effective.
Yeah. And for the participants, for the viewers who are not familiar with Prism, Prism is the name of we're going to host a AI eval reporting service called Prism, and it's not available to the general public yet, but we're working on making it available as soon as possible. But for now, like you just look at your test evals like once a day. You can set it up on a cron, and then like when it runs, you could ask your AI agent to report to you in Slack or something like that, and just let you know what's going on with them. In the meantime, we're setting up a hosted service that will keep track of it and give you good monitoring for it and stuff like that. And we're gonna give you a single place where you can have one subscription that'll give you access to Prism. It'll give you access to our bug fix agents and like lots of other stuff. So we're gonna introduce a bunch of new products very soon, over the next few weeks and months. We're gonna introduce a bunch of new products that you can use that'll really help you with your software engineering. In the meantime, our open source tools are all still open source. We're still very dedicated to open source and making sure that we have free tools available for people. But also there's, some things that you can only do with a hosted service and some insights you can only get when that hosted service is not shared, but there's like insights that you can get from aggregate usage of, lots of different companies doing lots of different things that can help everybody who's participating. So, but do so in a way where the everybody's individual stuff is still encrypted at rest and still secure, and nobody can see each other's stuff, and we're not using your stuff to train our AI models or anything like that. Without permission. You could probably opt in eventually, but we're not doing any of that yet. So the hosted services, there's real good reasons to supply those, right? They can do stuff that you just can't do with an open source piece of software that everybody runs decentralized on their own machines. There's insights you can gather from the aggregation of data that can help the entire community. So that's why we're building hosted services, and that's basically why we shifted the focus of Parallel Drive, and decided we're going to be building stuff instead of just building reusable pieces of software that everybody can use instead of just being a service agency. Because it used to be Parallel Drive's business model used to be, we would take on client contracts and build software for them and help them build development teams and help them build companies. That was Parallel Drive's way of operating. And then we built like a whole bunch of open source tools over like a decade. Our open source tools are in millions of products, billions of users, and we've helped build, multiple billion plus companies, billion-dollar plus companies, and billion-dollar plus products. But we decided we need to be a product company too, so that we can share more resources with the community. So, yeah. Okay, 6 major issues. Nice. And it's going to go in parallel dispatch to fix these. There's logic fixes, invalidate skill, test quality issues, docs commands. So hopefully, I'm going to get a summary of everything that it found, hopefully, eventually. I'm just going to let it automatically fix everything for now, and then I'll summarize, and then I'll undo the fixes if it made any mistakes. So, this is the process, right? We just automate our software development. And we're working on refining this to the point where you'll be able to build entire features or even entire prototypes with a prompt. And these processes will run and make sure that your product is production worthy, maybe even from a first prompt to production worthy prototype or MVP, in like hours or days instead of weeks or months. So that's the idea. And by the way, everything that you're seeing right now is running on the open source software. None of this stuff is our closed source proprietary stuff. The only closed source proprietary stuff that I'm using is, GitHub and Cursor Agent. Everything else is our open source software that you can use. And you can do these workflows yourself today. All right. And we're coming up on time. So does anybody have any questions? No? All right. Go ahead, Ian.
No, I'm good. Sorry, I was trying to find the mute button.
The only thing that I wanted to show you that I haven't shown you yet is the genetic programming command. Ooh, I'm really tempted. Okay. I think I need to create a new issue and show you the genetic programming command. So if I don't have it already, open. Do I have a gene splice? No. Okay. So I'm going to open a new issue to add gene splice to AIDD framework. Um, and I'm going to very quickly, I'm just going to have my little friend Victor create this issue for me. Here we go. I'm going to add gene splice to AIDD framework. I'm going to open a GitHub issue. Please give me a prompt that supplies the entire gene splice skill source code in separate blocks. If there are blocks in any of the files, use indentation to prevent breaking the outer code block. Please create the issue description complete with the um, source code files. All right. So I'm asking Victor because it's already there in Victor because I prototyped GeneSplice in Victor using GeneSplice. I had um I had a GeneSplice prototype uh, in my text replacements on my Mac OS, and I had it gene splice a prototype of the proper gene splice skill. So this what we're about to do is see the gene splice skill, but it's not in its final form. This is going to be like a version one iteration in AIDD framework, and I'm going to refine it and make it better. Um, but yeah, it's going to be cool. All right, I'm going to drill into that thread. Hopefully, it will paste the prompt before our time runs out, which is like 1 minute. I'm not going to have time to cover everything. And I have to go in a minute because I have another meeting scheduled right after this. So I can't just hang on. I think, I think, ooh, maybe I don't have to go because I don't see the meeting on my calendar anymore. Let me just see. Are we still meeting today or are you cool? Okay. Um, Victor. No, he hasn't responded yet. He's still working on it. And time is up, so we're probably not going to be able to see it today, but I will cover it in future stuff. And I use it all the time. Like, genetic programming is like the most useful tool that I've encountered in software engineering. So, quick story. I've got like 1 minute, right? Quick story. I had a friend. Um, okay, I'm gonna say, give me 5 minutes. Okay. So I had a friend, his name was Bill Scott. Really, really cool guy. He was VP of engineering for PayPal. And we were going to write a book together on software engineering leadership. Um, Unfortunately, he passed away. But during his lifetime, one of the things that he really did a great job of was he introduced the idea of he didn't like invent it, but he popularized the idea of using the UI layer as an experimentation layer and building lots and lots of different prototypes of the UI layer and doing and testing them in production using staged rollouts. And so part of your audience would get one version and another part of the audience would get another version. And then the one that actually did the best in real production environments would win. And so they basically were doing genetic programming, but humans were writing the code and humans were testing the software, right? But it was basically a survival of the fittest kind of mechanism. And it's called A/B testing or multivariate testing. And they would test like four experiments at a time. So they'd make like four different prototypes and test them all at once and then find the winning prototype. That only works at scale. Like if you've got millions of users a day, um, otherwise you're not going to get to statistical significance. But there's a much smaller variation of that that you can completely automate. So anyway, me and Bill have been using those kinds of techniques for well over a decade. And GeneSplice kind of brings this into the AI age and teaches AI how to do it. And it's a technique that I use all the time. Like I said, I've been using genetic programming stuff since like the 1990s. And I'm really, really excited to bring it into AIDD framework and hopefully popularize it much wider so that a lot more people start using it. Now, it is going to build multiple variations of the same stuff. So it's going to triple or quadruple your token usage per feature. But the quality of the features that you get out the other end of it is so enhanced, so much better. Like, so I think I'm on generation six of one of our prototypes, and comparing the generation six output to the generation one output, it is night and day. It's like a really good professional designer designed the generation six stuff, and like the generation one stuff was designed by, you know, a kindergartner with an AI tool, right? It's a huge, huge difference. Um, so yeah, genetic programming is a really big deal, and I hope that you guys all get to use it and have fun with it and learn how to put it to use because it's one of my favorite tools in my toolbox. All right, that's it for today. Thanks for joining, um, and we'll talk to you later.
Bye. Thank you.
Yeah, thanks, Eric.
Yeah, thank you, Eric. Have a nice one.